anything. I just thought it was interesting, right? So that's where the trigonometry comes from. The two Greek words trigonon, which means triangle, and metron, which means measure. So, as you may guess, trigonometry has to do with triangles, but in particular, they have to do with the right angle triangles, right? So it's not just any type of triangle. It's specifically for right angle triangles. And it deals with the ratios of the sides of the right angle triangles, right? So one of the main things in trigonometry, one of the most important thing is being able to correctly identify the sides of the triangle. Now, previously, you may have heard about the hypotenuse. Well, I know my students know about the hypotenuse. Zane, do you remember what is the hypotenuse in the right angle triangle?
Yeah, I think so.
What, tell me what you remember about the hypotenuse.
Well, I remember that the hypotenuse is basically the slanted side of the triangle.
Well, yep, but I mean, if I draw a triangle like this instead, a right angle triangle like this, then it doesn't really look that slanted, doesn't it? Does it?
Yeah.
So, who could tell me another thing about the hypotenuse in the right angle triangle?
Is the
Josh.
longest path?
Oh, okay. Who said that? Is that Soraya?
Yeah.
So the hypotenuse is the longest side in the right angle triangle, but most importantly about the hypotenuse is that it is opposite the right angle. So if this is the right angle here, the hypotenuse will be this side. Right? So the hypotenuse is the side that is opposite to the right angle in any right angle triangle. It is also the longest side of the right angle triangle, and that's an important fact to remember. But in terms of trigonometry, I want you to recall the hypotenuse as the side opposite the right angle. All right. Now, the other two sides in the triangle, in the right angle triangle, also have important names. And it's actually extremely important to be able to correctly identify those other two sides because based on that is how you would know which trigonometric ratio to use. And we're going to go on to trig ratios shortly, right? So in this triangle ABC, something I want you all to get familiar with here as well is that you see I use capital letters for the angles. So capital A for angle A, which is here, capital B for angle B, and then capital C for angle C, which is the 90-degree angle in the triangle, right? Now, the side that is opposite angle C would be the side C, and I write that with a common letter instead. And the side opposite angle A would be side A. And finally, the side opposite angle B is side B. Now you can also name the sides according to their endpoints. So like this side would be AB, this side is BC, and then the third side is AC, right? But you will also see it being represented like this. You'll also see it as where they use the capital letters, and then the sides are just the common letters, right? So side A would be opposite angle E, side B is opposite angle B, and side C is opposite angle C. In your list of formulae, when you do CSEC, and even like if you end up doing not NCSC, sorry, I forgot the name of the exam now that some of the schools do in Form 3, but you will have a list of formulae and it will be given to you when they're listing the trigonometric ratios. They use this type of labeling where the side opposite angle A would be side A, etc. All right. So the other two sides of the right angle triangle are of equal importance. However, you see how we identify the hypotenuse in relation to the right angle? We know that the hypotenuse is the side that is opposite the right angle. Well, the other two sides are not named according to the right angle. They are named according to our angle of interest, right? So in this triangle, ABC, Side A is opposite angle X, side B is opposite angle B, and side C is opposite angle C. We already know that the side opposite angle C is the hypotenuse, right? To name the other two sides, we identify the angle of reference or our angle of interest. And in this triangle, it's here, angle X, which is at really angle A. All right. So the side that is opposite angle A, right, is called your opposite side. So it's not complicated at all. All right. And then the third side, the side that is next to the angle of reference is called the adjacent. So for me, I find it easiest to always identify the hypotenuse first and then identify the opposite side because the hypotenuse is easily identifiable since it's opposite to the right angle, and then the opposite side is easily identifiable as well because it's opposite to the angle of reference. And of course, a triangle only has three sides. So the third side is what we call the adjacent side. So the three sides that we use with trigonometry or in trigonometry are the opposite side, the adjacent, and the hypotenuse. All right. And believe it or not, it's extremely important to be able to correctly identify those sides. So let's look at this one, right? If I move the angle of reference here, then, well, the hypotenuse will never change because it's always going to be opposite the right angle. However, the other two sides can be changed because it depends on where this angle of reference is. In the previous example, I had the angle of reference down here. So the opposite side was opposite that. But in this triangle, my angle of reference is up here instead. So the opposite side will be this side B, right? And the adjacent side is the third side. Okay. So the first exercise that we're going to look at is we're going to look at naming the sides in these right angle triangles here. So I'm going to number it. And I'm going to give you 2 minutes, no, let's say 3 minutes to name the sides. All right. Now, how I want you to name it is you'll tell me. So I'll just give you a little start. This is the angle of reference here. X is the angle of reference, and this is side A. So, this is angle A. So side A will be here because that's opposite angle A. Side B is here, that's opposite angle B, and then side C is here, right? So in your books, so when you're writing it down, you would actually say, I'm going to ask you, well, what is the hypotenuse? And you will tell me, well, the hypotenuse is side C or side D or whatever, right? That's what I want you to do. So I'm giving you 3 minutes to look at these questions and identify the sides of the right angle triangle. Let me just label from 1 to 8. What is the hypotenuse in, which side is the hypotenuse in question 1?
Between A and C.
Right. So that's side B, right? Because side B is opposite angle B. So yeah, this would be the hypotenuse. Good. What about the opposite side? Which side is the opposite side?
Between B and C.
Yes, that's side A or side BC. So this is your opposite. And then, well, of course, we only have one other side. So that's the adjacent. Thank you,
Yeah.
Josh. Soraya? Soraya, are you there?
Yeah.
In question 2, which side is the hypotenuse?
Um, the the one between G and E.
Okay, so that's side F, right? Because it's the side opposite angle F. So the F is the hypotenuse, all right. Where is the opposite side?
Opposite side. F and E.
Yep, that's side G. So, or side EF. And then, of course, the third side is the adjacent, right? So I always find it easy to identify the hypotenuse first and then the opposite. All right. Matthias. Matthias, are you there?
Yes, miss.
Okay, honey, tell me which side is the hypotenuse in question three?
Um, GI,
No, actually it's GH.
GH, yeah, yeah, I get
Yeah,
mixed up. GH,
yeah. Because it's the side opposite the right angle. Good. And then where would be the opposite side?
GI.
GI is the opposite side. Perfect. And then the third side is, of course, the adjacent. Beautiful. Zane, question four. Where is the hypotenuse?
Between M and N, miss.
That's right. MN is the hypotenuse, and the opposite side is
ML.
ML, correct. And then the third side is the adjacent, LN. Thank you. Um, who do we have? Joshua.
Yes,
Joshua.
please.
In number five, which side is the hypotenuse?
PQ.
No, actually, it's PR because,
Sorry.
yeah, your right angle is here. So then the side opposite the right angle will be PR.
Okay.
Yeah. Where's the opposite side?
Um, RQ.
That's right. That's the opposite side because it's opposite the angle of reference. And then PQ is the adjacent. Thank you. Did I give everybody a chance? I wonder if Faith, you could see the exercise, love? Probably not. All right. Soraya, let's go again. Which side is the hypotenuse? In question
Uh,
six.
I would say the one between B and C, come
Yes.
on, E.
Yeah. So that's the hypotenuse. Where's the opposite side?
The opposite will be A and B.
Yes. And then the third side will be the adjacent, AC. Beautiful. And then Josh P again, number seven. Where's the hypotenuse?
Yeah, but it's number 7, right?
Yes, love.
The hypotenuse is between C and E.
Yes. CE is the hypotenuse. And then where's the opposite?
Between D and E.
Good. And then the third side is
E.
the adjacent. Thank you. And Zane, in question eight, where is the hypotenuse?
PQ, miss.
That's right. And then the opposite is?
PR.
That's right. And then the third side is the adjacent. Good. Does everybody think they're okay with identifying the sides in the right angle triangle? Zane, are you okay with it?
Yes, miss.
What about you, Matthias?
Yes, miss.
Soraya, good to go?
Yeah.
All right. And Josh, I know you understand. Same Joshua, right? So let's go. All right, so let's now look at the trigonometric ratios. Before we could have moved on to the trigonometric ratios, we had to first be able to correctly name the different sides of the right angle triangles because the ratios are made up of those, right? So in this triangle, PQR, as you see, the side opposite angle P would be the opposite side. The side opposite the right angle is your hypotenuse, always. The hypotenuse is always opposite the right angle, and then the adjacent is the third side. All right. So in this triangle, the angle of reference is angle X, which is how I was able to identify the opposite and the adjacent side. So the sine of an angle is found by taking the ratio of the opposite to the hypotenuse. So you would recall, well, you would see it as sine x is equal to opposite over hypotenuse. All right. The ratio of the adjacent to the hypotenuse is known as the cosine. So the cos of an angle or cosine of an angle is the adjacent over the hypotenuse. And then finally, the tangent of an angle is the opposite over adjacent. Now, there's this acronym that we use in math to memorize the three trigonometric ratios, and it's literally called SOHCAHTOA, right? Where SO stands for sine, which is opposite over hypotenuse. That's where the SOH is about. CAH is the cosine of an angle. So you have adjacent over hypotenuse. And then TOA, tangent, is opposite over adjacent. I know it sounds very silly. But I learned SOHCAHTOA 17 years ago, and it stuck with me forever, right? So when you start to do tricks, I'm pretty sure your math teacher is going to like say it, and we feel real proud about it. But yeah, it really does help. Okay. So let's look at the sine of an angle. Okay. So in this triangle, you have triangle ABC, and we're going to look at what this really means. What is the sine of an angle? So if we're looking at the sine, which is found by taking the opposite and dividing it by the hypotenuse, the sine of angle x, this question says calculate the magnitude, so calculate the size of angle x using the sine ratio. The following steps can be taken. So you'll recall the formula that sine of x. You may also see this being represented as sine theta. Theta just is a symbol, it's a Greek symbol for an unknown quantity, right? So you could see sine x or you could see sine theta, it means the same thing. So sine theta is equal to opposite over hypotenuse. All right, so all we'll do there is we recall the formula and then we do sine, we write in the values. So sine of x is equal to, now in this triangle ABC, our angle of reference is here. Our hypotenuse is this side of 5 centimeters. Our opposite is the side of 3 centimeters. All right. The sine of the angle uses the opposite and the hypotenuse. So we write sine x is equal to the opposite, which is 3, over the hypotenuse, which is 5. All right, so that's the ratio. Now, to get what the angle x is equal to, you have to put sine inverse of 3 over 5. So does everybody have their calculator with them? What you're going to do on your calculator for me right now is you're going to press 3 divided by 5. Everybody do that for me. 3 divided by 5. And you should get 0.6. All right. So the sine of this angle is 0.6. Now, to figure out what the angle is in degrees, you have to press the second function on your calculator or shift, depending on if you have a Casio or a Sharp, and then press the key that has sine on it.
Miss,
Right?
can you repeat?
Yeah. Which kind of calculator you have, honey? Soraya, which calculator you
Sharp.
have? Okay,
Sharp.
so you're pressing 3 divided by 5. Press equal and tell me what you get.
0.6.
Good. And now you're going to press second function. You see, key that says second F.
Yeah.
Yeah, so you press that and you're going to press the key that says SIN. And on your calculator, you'll see SIN to the -1 come up on the screen. Are you seeing that?
Yeah.
Now press equal and tell me what you got.
36.869,
Good.
etc.
Perfect. Right? Did everybody get it? 36.8, well, approximately 36.87. Let me ask each of you. Josh, did you get it?
Yes, miss.
All right. Joshua, did you get it?
Yes, please.
All right. Zane, you got it?
Yes, miss.
What about you, Matt?
Yes.
All right. Faith? Faith, are you home now? Oh, Faith doesn't have a mic on. Okay, right. So this is how you find the angle. All right. So to find the angle, you always use the inverse function. And on your calculator, to get the inverse function, you have to press the second function key or the shift key, and then press either sine, cos, or tan. And on your calculator, right above sine, cos, and tan, you would see in a different color, maybe. You'll see sine to the power of -1, cos to the power of -1, and tan to the power of -1. This is called the inverse of the trig function, and we use that to find any angle, right? So the first thing we do is we identify the sides of the triangle, and then we determine which of the ratios we're going to use, whether we're going to use sine, cos, or tan. All right. So, so the angle is 36.87. And let me show you guys. It doesn't really matter which ratio you use, right? In this triangle, because we have all three sides. In some triangles, we will not have all the three sides, and you'll have to use the sides that are given to you to find the unknown angle. But in this one, we have all three sides. So you could have used cos or tan, right? Now let's look at so take note of the answer that you got, which is 36.87. And now let's do the cos of it instead. So the cosine of an angle, right? The cosine of an angle is the ratio of the adjacent to the hypotenuse. All right. So here, cosine of x is equal to adjacent over hypotenuse. All right. In this triangle, the angle of reference is x. So let's name our sides. The hypotenuse, of course, is opposite the right angle. So that will be the same. And then the opposite side, now in this triangle, if the angle of reference is here, the opposite side will be the side AC or side B. And then the adjacent side is side AB, right? Now, if we want to use the cosine of the angle, we would need to recall what the ratio of cosine is equal to, which is the adjacent over the hypotenuse. So what we write is we write cos x is equal to the adjacent side, which is 4 centimeters. So 4 goes on the top over the hypotenuse, which is 5. So it'll be cos x is equal to 4 over 5. So therefore, cos x is equal to, and you go on your calculator, 4 divided by 5, which is 0.8. And therefore, x will be equal to the inverse function, the inverse cos, so cos inverse of 0.8, which is, y'all check it on your calculator for me, please. I'm going to call somebody randomly. Check what is cos inverse of 0.8. You can also you could just type second function cos 4 over 5 and you'll get the same answer. Or you could do second function cos 0.8 equal sign and you'll get the same answer. Joshua, what did you get when you did the cos inverse of 0.8?
I didn't calculate it as yet.
Okay, tell me when you do.
Like, I still don't know how to really do it on the calculator.
Okay, what calculator do you have?
Scientific calculator.
I know which brand, sorry.
Um, Stanford.
Okay. Are you seeing, or can you, do you have your phone with you right now?
Yes, please.
Can you send me a picture of the front of your calculator so I could tell you what to press?
Okay.
Yeah. The others, anybody having trouble working it out? Please
No,
let me
miss.
know. Okay, cool. If you got it already, send it in the chat and tell me what you got. Round it off to 2 decimal places. And Josh, I'm waiting for the picture from you.
We picture what, miss?
Not you, Perez. Joshua. Sorry, honey. Josh, did you work it out?
On the calculator,
Yeah.
I got 0.8.
Okay, but did you find the cos inverse of that?
Oh, hold on.
You have to find the cos inverse of it.
36.869.
Yes. Um, Joshua, you send the pictures yet?
Yes, please.
I didn't get it. Let me see. On WhatsApp? Oh, yeah, now I got it. Okay, good. So what you're gonna press is right. So Joshua, you seeing where sine, cos, and tan is?
Yes, please.
Good. And then the first key on your calculator on the left top hand side says shift.
Yes,
So
please.
you have to press shift and then cos to get cos inverse. And once you press that, so press shift, press cos inverse, and then type in 0.8 and press equal sign and tell me. So
I,
shift.
yeah, I did it. I got 36.869.
Yes. Good. Perfect. So guys, do you realize that it's the same answer, right? Like the one above. It was 36.87. Zane, you got it, honey.
Yes, miss.
All right. Okay. So it doesn't matter which ratio I use, this angle is going to be equal to the same thing because it's the same triangle, right? And then finally, if I wanted to find the tangent of the angle, right? Or if I wanted to use the tangent, sorry, to find angle X, I'll do the same thing. The first thing that you always do when you're using tricks is you label your sides. So the side opposite the right angle is your hypotenuse, and of course, this is the same triangle. So regardless of where the angle of reference is, the right angle is in the same position. So the hypotenuse is always going to be that side with 5 centimeters in this specific triangle, right? And then the opposite side, well, the opposite side is opposite the angle X. So this is the opposite side here. And the adjacent side is, well, it's only one more side in the triangle. All right. So we recall the ratio for tangent, which is opposite over adjacent. So what you would write tan x is equal to the opposite side, which is 3 over the adjacent side, which is 4. So remember, TOA, tangent, opposite, adjacent. So therefore, tan of x is equal to 0.75, and therefore x would be equal to the tan inverse of 0.75. You'll punch that into your calculators, tan inverse of 0.75, and see if you also get 36.87 to 2 decimal places.
Yes, miss.
Yes, please.
Perfect. All right, I'm gonna write 2 dp
Yes, miss.
in brackets there. So as you can see, you get the same answer for the angle. It's the same triangle, same sides. So it doesn't matter which of the ratios we used since we were given all 3 sides. Now in questions, you will not probably be given all 3 sides. You'll just be given 2, and you will choose the ratio that uses those 2 sides that they give you to find the angle. When you are finding an angle, you always do the inverse trig ratios, the inverse trig functions. So you wouldn't just press sine of 0.7. You'll get the wrong answer. It'll have to be sine inverse of 0.7 or tan inverse or cos inverse. So at this point, we're going to take a 5-minute break. And then when you come back, we're going to do an exercise. All right. So take a 5 minutes, guys. And well, it's more like 6 minutes because it's 4:44, and let's start back at 4:50. You're gonna send it to me on WhatsApp so I could see how you're writing out your solution. Okay? So let's look at question 1 as an example. So in question one here, we have triangle ABC. The angle of reference is here, all right? Which means that this side is the hypotenuse AC. The opposite side is the side with 4 centimeters, that's side E, since it's opposite angle E. And then the adjacent side is the third side. It's next to or it's adjacent to the angle of reference. All right. Now, unlike the others, the other example, this triangle only has 2 given sides. So we have to use those 2 given sides to figure out which ratio we're going to use. And I'm going to just put the ratios on the side here for your reference. Sine of an angle x, so is opposite over hypotenuse. That's what the so means, right? So means opposite, sine opposite over hypotenuse. Ka, CAH, is the cosine of the angle, and that's equal to the adjacent over the hypotenuse. And then finally, TOA is the tangent of the angle, and that is equal to the opposite over the adjacent. Right? So I'm putting it there for your reference while you read. All right, so in this triangle, I am given the opposite and the adjacent. Therefore, the ratio that I need to use is tangent because only the tangent uses the opposite and adjacent. So the first line that I would write is tan x is equal to opposite over adjacent, just so that I recall the formula. The second line would be tan x is equal to, well, the side that is opposite, which is 4, over the adjacent side, which is 3. Now, on my calculator, I am just going to type in x, well, sorry, before I reach there. So therefore, if tan of x is equal to 4 over 3, now I could work that out and get a decimal, or I could leave it as is and just say x is equal to tan inverse of 4 over 3. Doesn't matter if I change that to a decimal like before, or if I leave it as a fraction. And all I'm going to do is on my calculator, I will type second function, tan, to get tan inverse. Make sure you see tan inverse on your screen. And then I press 4 over 3 to get 53.13 degrees. And I'm taking all my answers. That's part of the question, the working, guys. Sorry, the instructions. Give all your answers in this exercise to 2 decimal places. So I want you to write your solution exactly as is. You could copy down the first one as an example, and you're gonna do the rest of the questions. All right. I want to see every time when you finish question 3, so you're gonna do question 2 and question 3. When you finish question 2 and 3, send it to me on WhatsApp. I want to see your working. So go ahead and write out the example and then start with question 2. Send it to me. Let me know if you're having trouble along the way. I'm right here. The adjacent and the hypotenuse. Are you seeing the ratios on the side of the screen?
Cosine.
Yeah, it's going to be cosine, right? So what we write is we write cos of x is equal to the adjacent over the hypotenuse. So which number goes on top?
4.
4, and then 5 goes on the bottom, right? So it'll be cos x is equal to 4 over 5. So then x would be cos inverse of 4 over 5. You did that?
I don't know.
Okay. Well, you'll tell me your answer when you get it. Matthias, what you got, love?
There's a person I have to show my calculator because they give me one
Yeah.
set of
Yeah. Send it to me. Let me see. All right, Matt. So, oh, Matthias, your calculator right now is in radians. You see how it has RAD at the top of it?
yeah,
That means radians. So you actually have to change it to degrees. So you see in that key next to second function that has DRG,
yeah, miss.
press it, and you will see at the top, you'll see it has DEG instead of RAD.
It's what's that one?
It's supposed to have DEG instead of RAD.
All right.
Tell me if you're seeing DEG at the top instead when you press.
Yeah.
Yeah,
Okay.
good. Perfect. Now, what you're gonna do is you're gonna type, you're gonna press second function
Mm,
and cos to get cos inverse. So
mm,
you should see cos to the power of -1 come up on your screen.
yeah, miss.
Good. So, and now press, so we're looking for the cos inverse of 4/5. So 4/5. Um, where is the over button? I'm not seeing the fraction button. So you could just put 0.8 instead, because 4/5 is 0.8.
All right. So
And then press equal and tell me what you get.
5 by 0.8.
So cos inverse of 0.8, yeah.
112.5.
Okay, try it over. I feel you pressed something wrong. So your calculator is still in degrees, right?
Yeah, miss.
Good. So press in second function, cos.
Um,
So all you should see on the screen is cos -1. You seeing that?
yeah, I see it. Well, the number
Good.
say 99.
Okay, so clear the whole screen, press on to like clear the whole thing, and you're gonna start over, right? You clear it?
Yeah.
Good. So you're pressing second for L because that is the side that is opposite the angle of reference. So this is your opposite side. Now we don't actually need to label the third side, even though we know what it is. It's the adjacent side, but it's not even given, so we don't need it. Now, which of the ratios use the opposite and the hypotenuse?
Pardon?
Which of the ratios use the opposite and the hypotenuse?
Sine.
Which one,
Okay,
love?
wait. The sine one.
Yes, the sine, right? So that would be sine of angle x is equal to, well, it's the opposite over the hypotenuse. So it'll be 8/10.
Yes, please.
All right. So then that means sine x is equal to 8/10 is well, in your case, Matthias, you would do 8 divided by 10, right? Which would actually give you 0.8. So sine of angle x is equal to 0.8, and therefore angle x would be the sine inverse of 0.8. So Josh, tell me, work out sine inverse of 0.8 and tell me what you get.
I got 53.13.
Yes, that is correct. Perfect. Okay. Um, Zane, Zane, let's do question
Yes,
4.
miss.
All right. So let's label the sides. Which side is your hypotenuse?
MN.
MN is the hypotenuse. And then this side, LN, what side is that?
Ln is the adjacent side.
Excellent. Which ratio uses adjacent and hypotenuse?
Adjacent and hypotenuse cosine.
That's right, cosine. So cos of angle X is equal to the adjacent over the hypotenuse. What's my next line saying? It'll be cos of X is equal to what?
Is equal to 19 over 25.
Perfect. So therefore, X would be the cos inverse of 19 over 25, which is what?
40.53.
All right, let's see. 40.5. Well, it'll be 54 because if you're rounding it off to two decimal places, since there's a 5 after the 3, you would add 1 to the 3. So it'll be 40.54 to two decimal places. Yeah,
Yes.
thank you. Josh?
Me, miss?
Yes, honey, you. Let's do
All right.
number 5. So we
Yeah.
have the angle of reference here. Which side is your, well, this side marked 15. Which side is that?
Wait, 5. That would be adjacent.
That would be the opposite, right?
Opposite. Right.
Because
Yeah.
that's opposite the angle of reference. So this side will be your
Oh,
opposite. Okay. And then this side with 20, which side will that be?
adjacent.
That would be adjacent, correct. Because of course, PQ is the hypotenuse since it's opposite the angle R, which is the right angle. So this is your adjacent. So we are given the opposite and the adjacent sides. So which ratio uses opposites and adjacent?
Sin. I mean tan.
Yeah, tan, correct. Tan. So tan of X is equal to opposites over adjacent. All right, so now let's write this in. So therefore, tan of X is equal to the opposite side, which is,
20 over 15.
it'll be 15 over 20 because the opposite side is 15 and the adjacent side is 20 and the ratio is opposite over adjacent. So 15 will go on top,
Oh
right?
wait, that just messed up everything.
Oh, but do you
Because
see why?
yes, miss. Yes, miss.
Right. So then that means tan of X is equal to 0.75. The only reason I'm changing it to a decimal is because some of your calculators a little weird. So tan of X is equal to 0.75, which means X is equal to tan inverse of 0.75. What is that, Josh?
Let me check. Because I didn't have that on my paper. Because I thought it was 20 over 15.
Right. Okay, that's all right. So this is why it's so important to correctly label your sides, guys.
Miss, how to type it in on the calculator again?
You could press second function, tan, and then 0.75 and press equal.
So 15 over 20.
Mm-hmm.
20. And then after, what do I do?
Press tan inverse. So press second function and tan.
Alright. Second function. Wait. Second function. Yeah.
What you get?
Error.
Okay, so start over. So erase it and press second function, tan.
Mm-hmm.
Did you see tan to the negative one come up on your screen?
Yeah.
Good. And now press 0.75
Oh, I
and
didn't know
then press equal.
that. After I put in 15 over 20 and then tan, what do I put?
No. You're supposed to press tan inverse first of all. Unless you're doing 15 divided by 20 or 15 over 20 equal, and then press tan inverse of the answer. But you can also just do it from the beginning. So if you clear your whole screen and you press second function tan, you'll get tan inverse and you'll see tan inverse come up on your screen. And
Mm-hmm.
then you press 0.75 and press equal.
I got 36.869.
Yes. So this will be 36 point, if we're running off to two decimal places, it will be 36.87. Is that okay?
Yes, miss.
Josh, I need you to write the solution like this, right? Because I didn't see, when you sent me your work just now, I'm not seeing this line over here. This one. This part
Yes,
is
miss.
important, right? So I saw you had this, which is fine, but I need you to go from here to here with the x is equal to tan inverse of that.
Yes, miss.
So write that in for all of the ones that you have. If you notice all of mine, you see how I have x is sine inverse of 0.8 or x is cos inverse of 0.76, x is cos inverse of 4/5. You need that line in there, okay? All right, Matthias, let's do one together.
Yes.
All right, love. So let's go ahead and label the sides. Which side is your hypotenuse here?
Uranus.
In question 6, sorry.
Which one was good? Hypotenuse.
Yeah, which side is the hypotenuse in question 6?
Uranus.
Sorry, love, I didn't hear you.
Uranus.
RS.
RS.
Yes. So this side is the hypotenuse, the side with 50. And then the other side given here, which side is that? Is that the opposite or the adjacent?
Opposite.
Opposite. Which ratio uses opposite and hypotenuse?
Sine.
That's right. So we'll write sine of x is equal to opposite over hypotenuse, just so that we recall it. And then, so it would be sine x is equal to what? What over what?
30 over 50.
That's right, 30 over 50, which means, so on your calculator, check what is 30 divided by 50.
Yeah, Miss, how do you calculate it?
Oh, tell me what it is. Excellent.
36.87.
All right, I think so. I think so because sine x is 0.6, so x is equal to sine inverse of 0.6, which is, yeah, 36.87 again. X is excellent. You got the hang of it now, Matt?
Yeah, Miss.
Perfect. All right. Soraya, where is my girl Soraya?
Right here.
Hi, honey. Can we do question 7 together, please?
Okay.
All right. Okay, which side is your hypotenuse in question 7?
By E and G.
Yeah, that's my hypotenuse. And which is my adjacent or opposite?
F and G.
F and G is which side? Adjacent or opposite?
Oh, that's opposite.
No, actually, EF would be the opposite.
Oh, so then that's adjacent.
Yeah, right? The reason EF is the opposite is because it's opposite this angle here, which is our angle of interest or our angle of reference, right? So the opposite is always that side opposite to the angle of reference. Okay, Soraya, so we are given the adjacent and the hypotenuse. Which ratio uses the adjacent and the hypotenuse?
Cos.
Cos. Ka, correct. So cos of angle X is equal to adjacent over hypotenuse, which means that cos of X is equal to what over what? What is going in the numerator?
Cos of X is equal to 6 cm over 11 cm.
That's right. And therefore, X is equal to the cos inverse of 6 over 11. You worked it out already?
No.
Okay, check it out for me and tell me what it is.
$56.94.
56.94. Okay, let me see. I didn't work it out. Cos inverse of 6 over 11. Yes, 56.94 is correct. Perfect. And Joshua,
Yes, please.
let's do number 8 together. Okay. Which side is your hypotenuse in question 8 here?
H to G.
That's right. So that side is not really important because we don't even know what it is. Which side is the opposite?
Um, H to I.
No, it'll actually be GI. The opposite side is opposite your angle of reference. So you see how your angle of reference is here at
Yes.
H? The opposite side will be here, which is 16, right?
Yes, please.
And then the other side will be your adjacent. Do you recall which ratio uses the opposite and adjacent?
Um, I think is tan. The
That's
tan.
right. It is. So tangent of an angle is equal to the opposite over the adjacent. Okay, so therefore tan of x would be what over what? What is in the numerator and what is in the denominator?
It will be 16 over 13.
That's right. So then x is equal to the tan inverse of 16 over 13. Work it out and tell me what you get, love. Oops.
I got 50.90.
Tan inverse of 16 over 13. Yeah. Well, Josh, it'll be 50.91
Oh, okay.
because of the 6.
Yes, please.
Good. Perfect. Guys, let's take a few minutes again. And then when we come back, we're gonna do a little more of these. Yeah. Soraya, how come it's 4? How come it's decided with 4 and not 3?
Um,
Do you know? Do you know why it's decided with 4 and not 3?
no.
It's because the angle of reference here is angle O. All right. The opposite is the side that is literally opposite to that angle. So the angle O, the side opposite to that angle, is this side here. So that side VN is your opposite side. All right. Now, if the angle of
Okay.
reference, Soraya, if the angle of reference was here instead at V, then 3 would be your opposite side, right? But we are considering the sine of angle O. So that is our reference point. So whichever side is opposite angle O will be my opposite side. Cool? So sine of angle O is opposite over hypotenuse. So therefore, sine of angle O is equal to what will go in your numerator? Which number goes in your numerator here? Soraya, what over what?
It would be 4/5.
That's right. So the sine of angle O is 4 over 5. So therefore, the angle O would be equal to the sine inverse of 4 over 5. Now you could check what 4 over 5 is. 4 divided by 5 is 0.8, and then you find the sine inverse of that. This is one that we did already. Tell me, what is the answer? Sine inverse of 4 over 5. Soraya, you working it out, honey?
53.13.
Yeah, 53. It's funny, I think you actually worked this one out before as well.
Yeah.
All right. Zane. Zane, let's do number two together.
Customers.
So we're looking at the tan of angle O. So that angle is over here. Which side, which sides do you need for the tangent of the angle?
The opposite and the adjacent.
That's right. We need the opposite and the adjacent. Good. So which two sides? That would be tan O is equal to. Which side is your opposite here?
Um, R and X. Miss.
Yeah, so that's 12. So this is your opposite side because it's opposite your angle of reference. And then the adjacent is which side?
X and O.
Actually, that's the hypotenuse.
Oh, yeah. Sorry.
Yeah.
R and O. Sorry.
Yeah, because this is opposite the right angle, right? That side with 37. Good. So 35 will go here. So it'll be 12 over 35. And therefore, O would be equal to your tan inverse of 12 over 35.
Yes,
Can you work
miss.
it out and tell me what it is?
18.92.
Yes, 18.92 is correct. Good. Thank you, Zane. Josh Perez. Where is my boy Josh? Was it Josh that just told me he's no? Josh, are you there? Josh has a coffee break right now. Okay. Matthias,
Yeah, miss.
let's do question three together, honey. So it's tan of angle H. So that means our angle of reference is at H. Which sides do you use for the tangent?
Tangents, opposite and adjacent.
Correct. Which is your opposite side in triangle EOH?
EO,
Yes, that's your opposite side. And which side is your adjacent?
uh, EH.
Correct. EH is the adjacent. Perfect. So then I would write this is opposite is 45 and adjacent is 28. So therefore, the angle H is equal to tan inverse of 45 divided by 28. Work it out for me now.
Yeah, miss. 58.1.
That's correct. Matthias, can you round it out to two decimal places instead? So 58 point what?
58.10.
Well, 1 right?
Oh, yeah, 58.11.
Yeah, because the number after the zero is a 9. So you would add 1 to 0 to make it 1.
Yeah.
Great. Let me see if the Joshes are back. Josh Perez, are you back?
Yes, miss.
Let's do question four together. Which which sides which sides do you use in the cosine of the angle to find the cosine of the angle?
Um, opposite and with adjacent and hypotenuse.
That's right. Ka, adjacent and hypotenuse. So which side is your hypotenuse in this triangle VBC?
Between V and C.
Good. So this is your hypotenuse here. So that goes on the bottom. And then the adjacent side will be where? Your angle of reference
Um,
is C, right? Because it's cos of C we're looking at.
adjacent to be between B and C.
That's right. The adjacent is 56. Good. So cos of angle C is 56 over 65. So therefore, C is equal to cos inverse of 56 over 65. Work it out for me. Tell me when you got it, okay?
Yes, miss. Miss, I get error again.
Okay, so type clear everything. Press, you have a sharp calculator, right?
Yes, miss.
All right. So clear everything. Press second function. Cos.
56,
No,
50.
not anything as yet. You're just pressing second function and cos to get cos
Okay.
inverse on the screen.
Yes, miss. I got it.
Once you get that, press 56 over 65 and then press equal.
I got 30.51.
Correct. 30.51. Okay. Joshua, are you back as yet? I wonder. I don't feel so. Joshua is not back as yet. All right. Soraya, let's do question 5 again. Soraya, are you there, honey?
Yes, miss.
Okay, we're looking at question 5. So which sides do you need for the sine of the angle?
We would need 77 and
No, tell me the name of the sides, honey. Sorry, I wasn't clear
oh,
with that.
opposite and hypotenuse.
Hypotenuse, correct. The opposites and the hypotenuse. So we're looking at sine C, all right? So this is your angle of reference here. So which side is your hypotenuse?
Hypotenuse is 85.
Good. And then the opposite is the side opposite your angle of reference. So which side is that?
36.
Correct. All right. And then the adjacent will be the 77. So the opposite is 36 over the hypotenuse, which is 85. So therefore, the angle C is equal to sine inverse of 36 over 85. Okay, Soraya, work it out and tell me what you get, please. You got anything yet, love?
Ah, yeah.
Okay, waiting. I'm waiting for you. Take your time.
Mm. This is the answer 25.06.
That's correct. The answer is 25.06 degrees. 25.06 degrees. Good job. All right. Who wants to do the last one? I wonder. Joshua, are you back as yet? Joshua isn't back as yet. Okay, somebody who wants to do the sixth one with me?
I did this.
Okay, let's go, love. So which ratio do we need for the cos? Sorry,
Adjacent
not
and
which sides? Yeah. Adjacent and
hypothesis.
good.
Hypotenuse.
Hypotenuse. Good. So in the triangle, here we're looking at angle T. So which ratio is, sorry, why did I say ratio? Which side is the adjacent side?
Um, this outside is
Well,
ST.
let's identify the easier side. Yes, correct. It is ST because that is the side next to the angle. Adjacent literally means next to. So the side that is adjacent to the angle of reference is your adjacent side. That's why it's called adjacent. It's literally next to it. And then which side is the hypotenuse?
UT.
Yeah. Good. So cos of angle T is equal to the adjacent, which is 20, over the hypotenuse, which is 29. So therefore, angle T would be equal to um
46 points. Sure. No, 46.4.
let me check it. I didn't check it as yet. Sorry. I was just writing it. Okay, so cos inverse of 20, cos inverse of 20 over 29. 46.4 is correct. Excellent. 46.4 degrees. Good. It gets easier, I promise. The most difficult thing is correctly identifying your sides. And as you can see, let me just save this. Right. If you don't correctly identify the sides, you will actually use the wrong ratio, right? So it's really important for you to identify the correct sides in the triangle. So guys, we're gonna stop there for today. Matthias, I will send you the Google Classroom information to join. I'll send it to you. The number you messaged me from, is that your phone?
Yes, miss.
Okay, good. So I'll add you to our group chat and I'll send you the Google Classroom because I'm going to post this on Google Classroom. And I'll also post